Morning Year 4, this is our Wednesday's lesson about fractions, and today we're going to be moving on to subtracting fractions or taking away. So before we start anything, if you could pause the video and write today's date and learning objective, please. So when we're subtracting fractions, we need to know that only the numerators change when we subtract fractions, just like when we're adding fractions. We're going to be using bar models to help with subtracting fractions, and we're only going to be subtracting fractions with the same denominators. So just to get our brains warmed up and thinking about fractions, have a quick recap on what we were doing yesterday. So we've got a bar model here, and what calculation do you think it is showing? It is an addition calculation. So what calculation do you think it is showing? Well done. If you have said 2 quarters add 1 quarter equals 3 quarters altogether. We can add fractions when their denominators are the same, the number at the bottom of the fraction. So we add the numerators together and the denominator stays the same. So that's for when we add fractions together. But we can use that to help us when we subtract fractions as well, because it's the same rule. The denominator doesn't change and we just subtract the numerator. So if you have a look at the bar model up here, now it was split into 4 equal pieces. So the denominator of our fraction is going to be 4, or quarters. 3 of those quarters were coloured in blue. So we started off with 3 quarters and we took away and we crossed out 1 of those quarters. So how many quarters are left? Shout the answer out. Well done. It is 2 quarters, which is also equal to 1/2. So let's see if you can draw some bar models to help you subtract the fractions. The first one says 5/6 take away 3/6. So you need to draw a bar model, and remember your denominator tells you how many equal pieces you cut it up into. So you start with a bar model that's chopped into 6 equal pieces because the denominator is 6, and you would shade in 5 of those pieces. Then you're going to cross out 3 of those pieces, 3 of those 6s, and then work out how many are left. Remember to draw a bar model for each of the questions, but remember the denominator tells you how many equal pieces it must be chopped into. Pause the video where you have a go at those 4 different questions. Now you can have a look through your answers. So 5/6 take away 3/6 is 2/6. 9/10 take away 4/10 equals 5/10. Remember the denominator stays the same, the numerator you can subtract. 9 take away 4 equals 5. 11/12 take away 5/12 equals 6/12, or you could have written 1/2. And then the next one, you had to subtract 2 fractions from another one. So you start off with 6/7, you take away 2/7, you then subtract another 1/7, and that leaves you with 3/7. I wonder, did you get those right? So you'll go have a look at some fluency. Now, for activity 1, you have to look at the bar models and write down what calculations are represented and then work out the answers. So for A, for the mild challenge, look at how many bars how many pieces the bar model has been chopped into. So 5 equal pieces. So the denominator of your fraction for A is going to be 5. Then work out how many are shaded in yellow, and then take away how many are crossed out. Then you work out how many fifths are left. So choose your challenge. That's activity 1. And then for activity 2, you complete the calculations, draw some bar models to help you. And then remember, the denominators don't change, only the numerators. So pause the video while you choose your challenge, and then you can press play when you're ready to mark your work. Okay, so here's the answers for the fluency questions. So you can pause the video while you mark your learning. Remember, if you got anything wrong, you can always track back through your work, see if you can spot where you've made a mistake, maybe talk it through with one of your grown-ups, or just try and work it out again and see if you still get the same answer. Quite often you get a different answer. You might work it out in a different way, or you might draw a bar model to help you. So let's go through a couple of reasoning questions actually together. So a cake starts off with 8 slices. That looks like a delicious chocolate cake, doesn't it? So a cake starts off with 8 slices. If Meg has 6/8 of the cake left, and then she eats another 3/8, how many slices does she have left? Have a little think about that. Pause the video where you have a think and get an answer in your mind. Okay, so she started off with 8 slices, but it sounds like she'd already eaten 2 because she only had 6/8 of the cake left. Then she ate another 3/8. So how many slices did she have left? Well, if we do 6/8 subtract 3/8, that gives us 3/8. That means 3 out of those 8 pieces are left. Now, this one's slightly more tricky. A large pizza has got 12 slices. If Jake has 9/12 of a pizza left and eats another 1/4, how many slices does he have left? Just pause the video where you have a little go at this. Now, what I didn't tell you is that if we remember back to our work on equivalent fractions, remember when we subtract or add fractions, our denominators need to stay the same. So we have got to make 1/4 into a fraction that is an equivalent amount of 12ths. So 1/4 is actually equal to 3/12, isn't it? So let's read the question again, and instead of saying 1/4, we say 3/12. A large pizza has 12 slices. If Jake has 9/12 of a pizza left and eats another 3/12, how many slices does he have left? So what we're actually calculating is 9/12 take away 3/12. Our denominator doesn't change. So we do 9 take away 3, which is 6. So we have 6 out of those 12, or 6/12 of the pizza left. Or you might have said that 6/12 is equal to 1/2. And well done if you work that out. So there are 6 out of the 12 slices left over. Now, for your reasoning, I want you to see where the mistakes are in these questions. So there's some children that have worked out some subtraction calculations, but they've gone a little bit wrong. And I want you to work out what should the answer be and what mistake did they actually make. So pause the video where you have a go at the reasoning now. Okay, and there you go. You can mark your own reasoning. Pause the video where you do that now. So, problem solving. How many different ways can you balance the equation? So, when we balance the equation, the answer on one side has to be exactly the same as the answer on the other side, so that they are balanced. One isn't any more than the other. So, we would look at the side of the equation where we know some definite numbers. So 7/10 take away 3/10 is 4/10. Well done, because our denominator stays the same and we subtract the numerators. So 7 take away 3 equals 4, so 4/10. So what is 4/10 equal to? So I've got a solution here. 4/10 is equal to 3/10. Tenths add 1/10. But is that the only answer? Did you think of anything else? So have a go at some problem solving are the same kinds of questions where you have to balance the two sides. So for the mild, 7/8 subtract 3/8 equals 3/8 add something. So you have to work out the first bit of the equation, the subtraction first, to work out what you've got to balance the other side to, what it must add up to. But for the spicy and the extra hot, it might have more than one solution. It might not just have the one, it might have more than one. See how many different solutions you can find. So just pause the video while you have a go at the problem solving for today. When you've done that, you may mark your own answers. You will see for the spicy and extra hot, it says various answers. As long as they add up to 5/9 for the spicy and 7/12 for the extra hot. So I've got an extra challenge for you today. Now, we know that subtracting and adding are the inverse, the opposite of each other. So what I'd like you to do is work out what are the missing fractions on each of these diagrams. So 2 blocks added together makes the block above. So if we look at number 1, we've got 6/12 and we've got 2/12 and we've got 1/12. So if we look at the first two, 6/12 and 2/12, if we add these together, we end up with 8/12. So that would go in the first box. And then we've got 2/12 add 1/12, which equals 3/12. We could add that together to the 8/12, and then we end up with 11/12 in the top box. Some of them you're going to have to subtract, some of them you might have to add. Remember, they're the inverse of each other, so they kind of go hand in hand. Good luck, and I'll see you tomorrow.